to the Graphisoft Community Workflow webinar series, and this is now episode 3. So for those that have missed out on the previous 2 episodes, I encourage you to go onto the Graphisoft community and watch the 2 previous episodes, or go onto the Archicad channel on YouTube. For those that have not met me before, I'm your host, Nathan Hildebrand, and today I have Graham Whipple from Resin Architecture from Idaho Falls in Idaho, the United States. Now, Graham, I have to admit, is actually one of the most intriguing or interesting guests I've ever had present. Now, I've introduced a lot of people at a lot of conferences over the last decade, but you know, I've actually learned that Graham has the longest streak, and I call it the world's longest streak, in Duolingo, and he's learned a lot of languages. Okay, and the joke was today is he learned a lot of languages, including Hungarian. So, you know, maybe he's preparing himself to move to Budapest sometime in the future. So that's kind of, I guess, my my prediction for the long-term future. But today, Graham's presentation, Leveling Up Through Integrated Design, I feel is actually quite a timely one. As we find ourselves in the profession of architecture, it sees us needing to collaborate more and more with stakeholders. And today we're going to discover processes that Graham and Resin Architecture have been using to facilitate integrated design. Now, throughout the presentation, if you have any questions, you know, please feel free to put them into the chat. At the end of Graham's presentation, I'll ask him your questions on your behalf, and you may even have the ability to chime in, and we might open up your camera or microphone if you have a more detailed question. But that's enough from me today. Now I'd like to hand you over to Graham and his presentation. So take it away, Graham.
Thank you, Nathan. Can you see my screen now?
Yes, we can.
Okay, great. I want to give just a little bit of an overview of where we're going to go today. First, I want to talk about a little bit more history and background to Resin Architecture and how we have found ourselves in this need and desire for integrated design, and then a little bit of the why integrated design and how we've found our footing there over the years. And then we're going to look at hopefully 4 projects that show different levels of of integrated design and how we approached that with different scale projects based on the needs of those projects. So to start, I just want to talk a little bit then about Resin Architecture. We are based in Eastern Idaho in the United States, and the images here that are colored on the map, the states that are colored, are those that where we have current active projects. We do collaboration with other firms and other professionals in other states as well. So for a small firm, we have a pretty good reach, and our firm is based on a handful of core values, being consistent and committed and creative and dedicated to teaching and learning. So it's really great to be part of this series because it builds not just the culture within our own office, but outside our office as well. I want to then talk a little bit about my path and how I got here. I started in Archicad in version 6.5, which is kind of a long time ago, about 25 years ago. And what really impressed me at that time was the idea of virtual building. The idea that we could develop something as it could be constructed in real time. And that changed the mindset of my work. Nathan mentioned that I have a very long streak on Duolingo. That this is a little bit about me outside of architecture. The 7.5 years that have been consistent have involved a lot of languages, but basically I love to learn. And then there's a book called Homo Ludens, which means man, the player, from a Dutch author. And that also influenced me 30 years ago when I first read this book, and has continued to play a role in the way that I think and work. And it's the idea that through play, we actually learn a lot. We learn strategies. We find creative solutions. We learn to work within boundaries that maybe are fixed, but we find a lot of room to play within those boundaries, which lead to success. And then on the side, when the internet goes out, or when I just need some downtime, I really go old school. I have an old printing press from 1887 with movable type, and it's an art form known as letterpress. So this is upside down and backwards. And I might set some movable type and then print some artwork or custom cards or other. So that's a little bit about my history and background. Now, I want to focus here for a moment on some of the highlights that were mentioned here. I want to make sure that we understand various integration techniques and their pros and cons. So we'll do that as we touch on these different projects. I want to then also identify barriers. Those are kind of the boundaries, the game rules that we need to be able to work within. And then we'll talk about ways that, regardless of the project size or complexity, there are ways that we can do more to integrate. And so that's where we want to go there. Now, why integration? As we set up Resin, and through the history, my professional history, I saw a core need to have better integration of structural, mechanical, electrical, plumbing, because those are very much integral to the basic building. The interiors are what makes things just beautiful and really identify with our clients. So here at Resin, we have worked to develop a minimum level of integration in pretty much every project that we do. And why do we do that? Well, there's a few things, and I want to share a few case studies over the years. I do want to give a caveat here, though. I don't claim to be the absolute expert in this. We have had challenges over the years. We have found successes in doing this. So really, I hope that through the duration of this presentation, you're inspired to see ways that you can find successes. This building is a C-store truck stop at a significant crossroads in rural Wyoming. Well, this was a very early project for Resin Architecture, and the power of Archicad and the collaborative integration with IFC was extremely helpful in this project, because when we received the IFC file from the pre-engineered metal building manufacturer, we found out that the building had been ordered and was being engineered and manufactured 2 feet taller than our original design. And because we were able to take, and here you can see how the entire metal building is, the IFC from that metal building is integrated. This red portion here was our original assumptions in Archicad, and then the purple and all these other elements came in from the IFC model. And we were able to then adjust on the fly before the materials needed to be installed for the exterior facade. We knew that the panels had to be 2 foot longer and that we needed a certain amount more horizontal siding. And we were able to adapt before it became critical and avoid delays. So that was a real game changer, eye-opener in the reason why integration is so important. Another example is, looking to see what other industries speak the same language, whether it be IFC or other 3D geometry. I have a project a number of years ago where we developed a really detailed handrail, and in working with the metal fabricator, as soon as I mentioned IFC, his eyes lit up. And he's like, whoa, I've never known anybody that can speak IFC with me. And so we took the original design we exported to IFC, and you see the model here in Celebri, and he was able to take that information into his software, and with about 98% of the work already done, he was then able to fabricate a handrail that matched our original design intent. And so that's really a great thing, to be able to think, well, now we're pushing the data back to the fabricators. Early in design, as we're talking about finding room for systems, plumbing and ducting, especially in combination with structure. If I have a sloped plumbing line that needs to find its way up through, well, do I have enough room here at this condition between an assumed floor truss and a load-bearing wall? And at what point does that pipe then end up below the depth of the floor? And hopefully it doesn't at all, so that I can keep that all within the floor pack. It allows me early on to see conflicts and to be able to think, well, once I get triangulation in these trusses, does this rectangle need to become round? Can we maintain as a team the same volume, and we can have that collaboration? Then we bring our clients in and we walk them through the building as we're putting these spaces together. Resin Architecture has a guarantee in our workflow that our clients will be able to walk through before they break ground. And this is very, very important for us. We've seen a lot of movement in the technology that has given great opportunities for this. We can take it on our tablet to the job site, and we can confirm that the building in construction is aligning with where our original vision is. And that vision, even on the iPad or on the desktop, can be experienced by the client, early on. So that's the why. And I think, hopefully everybody here understands and has a desire to jump into this a little bit. So there's a couple of paths that Resin has found over the years to work to achieve this. And one is native within Archicad. Well, we're very familiar, hopefully everybody listening today, with the Teamworks interface and the potential of Teamworks. So what happens then when you start to invite non-architects into your model? What happens when the structural engineer is live in your model? What happens when a mechanical engineer is live in your model, and an electrical engineer and an interior designer? Well, it could be chaos, or it could be absolute awesome. So every game has a set of rules. Playgrounds have rules. And this idea, homo ludens, man, the player, we have rules. And so Resin Architecture, we developed early on, we developed a set of rules as we invite you to our playground. We review best practices for our workflow within the Teamworks environment. And we cover things such as simple send, receive, reserve, release all. And, kind of the guidance that, hey, if you're going to step away from your desk to take a phone call or to step into a quick conversation, make sure you do a send and receive. Teamworks has come a long way over the past 20-ish years since I first used Teamworks. And the data integrity is way better than it was in the early 2000s. But still, things happen. And what happens when that 5-minute phone call or that slight distraction that pulls you away from the desk ends up being an hour and somebody's reliant on that? So we talk about the communication process. We talk about joining and leaving projects and what is necessary there. We talk about attributes, and we actually assign attribute sets. So for example, here in this document that I've pulled up, we're assigning a set of layers and a requirement that there be a prefix that represents that company. And if I remember, I'll show an example of that. We assign pen sets that are dedicated so that no matter what pen combination we use, we know that this set of pens is dedicated for structural, and that we shouldn't ever be using this. And then we have sets for mechanical, electrical, plumbing, and then other specialty sets. We talk about layer combinations and how, for example, a prefix that that identifies those layers and then is also descriptive to what that is, what is contained on that layer. Very consistent with what we all do most likely with the architectural systems. And then we talk about graphic overrides and model view options and the project map. I mean, this is all stuff that as Archicad users we recognize, and then we ask for those team members in our consultant office who are going to be involved in the project, that they have reviewed this, and we ask for their approval so that we know that they're accepting the playground rules. That's very important. We don't want to bully on the playground. So once we know who is coming to our playground, we go into the BIM Cloud Manager, and we make sure that we have the appropriate roles. Now, by default, there are a number of roles here, but let's say that this is the first time you have a structural engineer in your model. You may not want to grant them complete access. You might start with a viewer role, a structural viewer even, that has, you can go in and you can customize roles depending what the needs are. And so we do that. We create custom roles depending on the team members and their experience. And then we get people onboarded into the TeamWorks project. Then there's a little bit of management for the BIM manager in your office, or just general housekeeping. It's not extensive that is needed, but what we do is we go in occasionally and we check to make sure that, for example, that the layers are within the layer combinations and the other attributes are within the series of numbers that we've assigned. And in versions 26 and 27, there's all kinds of improved and new ways to do attribute management. The projects I'm showing you today all happen to be in Archicad 25, and it's not because we're working only in Archicad 25. That was actually just interesting to see that these projects that span the last 7 years at some point all came into Archicad 25. And so that's kind of where we've started. And then the management within the TeamWorks dialogue, and how we have the communications here, and we can see who's online, and the send and receive, and we go through all of that. So this is hopefully not unfamiliar territory yet to anybody, and we're going to get here into more meat. Now, okay, that's native within Archicad. Now there's a whole other pathway to integration here, and this is related to OpenBIM and the IFC format. As we look at this, we have an opportunity to bring in IFC files that are generated in other software solutions. A lot of our consulting engineers want to work in a software that is comfortable to them. And I'll show examples of this, where we have it native within Archicad, and we're working collaboratively also with IFC. So, if you're not familiar with this, there's a lot of learning that can happen here through IFC and the translators and things like that. One of the things that we recognize as we jump into working with IFC is not all of the data is equal from program to program. Some programs have more ability to customize data. Archicad is actually very powerful through classifications and properties to be able to create lots of kinds of data that isn't necessarily in the standard IFC framework. And through translators, we can take those custom properties and we can map them to IFC related properties. And in doing so, we can take those properties and make it so that on the receiving end, when our consultants receive that information, it's appearing correctly in the IFC format. The property mapping for IFC translators can get actually quite complex. I'm not going to dig deep into that today because there is a lot of complexity. The thing that is important here to know is that we have a lot of power in how we're exporting and mapping those things out to IFC. We don't have a lot of control in interpreting the data as it comes back. Let's say that we get a file that was generated in Revit, and as it comes back in, we can map certain properties from the IFC format back. But because this is being produced outside of our control, we don't know the integrity of the data that is being put in the IFC format. And as we get into the IFC format, there are huge amounts of opportunities to classify information. And so we have to be aware that that information will come back in through IFC potentially differently than how we would natively work within Archicad. Okay, that's a lot of foundation information. Now I'm going to start with a rather small project here. This project is a very modest vacation home, and I'll just toggle back and forth here as we're looking at some of the inspiration images. So first, this project is on a riverfront with views out the living space to some mountains and to the waterfront, and the ability to walk out right out to the river. And so in working this, you know, this could be a $1 million house or a multi-million-dollar house, or it could be a very modest house. And our client, although he has the resources to be able to probably do a full-blown integrated design, there's not a huge benefit to that in this scale of project. So we worked in a very stripped down way for integrated design in this project. And I feel that this is very achievable for every single Archicad user. And so I'm going to talk through some of what's happening here. What you're seeing here is the bulk of the architectural is now transparent in wireframe, and you're seeing the entire structural system. Well, okay, Resin Architecture modeled that structure. It's not hard for us to model that structure. We're not structural engineers, so how did we know what the structure needs to be? Well, so we come back here, and what we did is we shared a set of base drawings with our consultant, and they just went through and they marked it up for us. They said, well, we are here, you know, here's your framing at such and such level, and here are the beam locations, and in this particular project, this is a structural engineer that we've worked with on much more complex projects. So they really were coming in our Archicad file mostly as a viewer in this scenario, although they had more permissions than that. And so as Resin then took those red lines and started to develop things, we found some interesting conditions and details that we needed to just work through with the engineer. You know, how are we doing connections here, and how are we going to make sure that our deck that is exterior drains off, and what are the connection opportunities here? And so this is where our structural engineer that normally we would work very very deeply with on a project, they came in and they would explore the model in a way that they could understand the exact conditions rather than us taking and translating, you know, half a dozen half a dozen different conditions and hoping that they understand the 2D correct. So they would take that then and they would go and develop details so that we could integrate and develop those further. Then another level of integration that we have here on this project relates to the interior design. Our client here had a certain number of inspiration images that were driving the aesthetic for this residence. And what we then did as Resin Architecture is we went in and we developed the interior to a level where we could take these images into external software to get better renderings. But for this particular client, he didn't need photorealistic images of his building. He did the VR, he did BIMX as he was living remote, and he just wanted to understand that the paneling here would be similar to the paneling that he's seen in the inspiration images. And then we were able to link the exact materials back as our internal interior designer was working with those specific finishes, fixtures, and cabinet styles, et cetera, and colors and surfaces and such. And so here, this was a very kind of low-tech way of developing the model so that we could understand what is happening here. So I feel like this is a very achievable level of integration, of integrated design for anybody who's using Archicad. And the way to entice your engineers in is to show them the power of the visualization. So when we're here and the engineer starts to understand that you understand the detailing and you desire to understand the detailing and the assemblies, then they will be more on board. This is where I started in my workflow with the engineers back in about 2014, 2015, as I was pulling engineers into the project. Okay, the next project here I want to talk about is a small commercial mixed use building. It has two primary tenants, and this project here was done all natively within Archicad. So we got our structural engineer, same structural engineer. We got our structural engineer in here. We got a mechanical MEP engineer, and everything was modeled within Archicad. Now, the top and bottom chords of the trusses, this is actually a steel truss that is representative. Okay, these would actually be dimensional lumber at the top and bottom. So it's not 100% accurate, but it's very representational of what we actually would be seeing here. And in doing this natively in Archicad, there is just a really great opportunity for us to be able to say, through the Teamworks process, we can go in and we can assign elements, which I'm not seeing at the moment. Yes, right here, assign elements. So using the Teamworks process, we can continue that dialogue, send them the messages. They're not in here probably every single day, so we might follow up with a phone call. We might follow up with an email and say, hey, I sent you some messages through Teamworks. Now, the other thing that is powerful within native elements within Archicad is that we have the opportunity to assign classification sets and custom properties. And so, for example, Resin Architecture, we have developed a keynoting system that is not the focus of this presentation, but we've developed tools through classifications and properties. And because we have native elements, we can assign intelligence to native Archicad objects. Now, I'll talk a little bit more about limitations using IFC, but needless to say, there are limitations to that same kind of ideal workflow. So here we have this entire model built to convey things to our client, and then an important part of this project dealt with the branding of this convenience store. And so we were able to put all of their new updated branding in and then generate images that would allow us to convey that information to the client, to take this in. And similar to the interior design process on the prior project, we could use traditional boards, we could use physical samples, we could use photorealistic renderings. But the reality is the geometry needed to be intact. The other thing that's powerful here is that over time, there were a lot of changes. Changes happen on projects. We know that. So in this sandbox model that I'm showcasing today, I'm aware that there are some conflicts. It appears that maybe a duct got moved. This is running right through the middle of the truss. It's not perfect, but as this project was under construction, we were able to do coordination here, and then there was actually a part 2 to this project where a second tenant came in on this half of the building, and so now using hot links and using shared data, we have multiple projects. This project probably started in Archicad 22 and ended up in Archicad 25. So over a period of years, we went from concept ideation all the way through construction in this project. Okay, let's see, what else was I going to talk about here? Within this model, now we are able to also see that, for example, mechanical equipment that is defined by the engineer does not need to be duplicated. If we bring an IFC object in, then I might have an IFC object as a space holder that is geometrically correct. But in order to add intelligence to that, in order to give a unique ID or to use keynoting or other, I need an Archicad object. And so here, when it's native to Archicad, I only need one object. And so then the goal is to try and find the most geometrically accurate representation of that. And then we can build the intelligence in. We have a lot of great tools now over the years to build that intelligence in. Okay, I'm looking at time. So I want to make sure that we touch on these last couple of projects. This project here is a large commercial project, and this project was very speculative in nature. There was only one tenant that was actually confirmed to be in here at the time we were developing this. And so a lot of what we were doing here was very speculative in how the space would be defined. And we knew that we had some common systems that would need to reach to all areas of the building, and we had major structural elements. And so we did just limited coordination with our MEP team and the structural team to make sure that, for example, when we needed to be underneath a beam, that those were accommodated, and that we could clarify and identify to the eventual tenant that you need to plan on a dropped ceiling, or this is the maximum ceiling height in this area for this reason. There were also some very critical areas adjacent to elevator shafts, and to get air inside and out of the building, fresh air down major corridors. And so with that, we really just focused on the coordination from an MEP side of those common areas of the building. And then when we go to the basement, where fluid flows one direction, and once there's a concrete slab placed over things, it's really hard to adjust the depth of potential drain conditions. And so here, by modeling, by coordinating with our MEP team to have the plumbing lines accurately modeled, we were then able to know, for example, that the real time because there's, you know, a little bit of lag. We were able to know what the elevations were at different critical locations in the system. And then the reality is, as this moved forward, the layouts completely changed. But by the time we knew what the layouts would be, we had shifted the layouts probably a dozen times, very speculative. And so now I know that I have plumbing waste that needs to get from here over to here. And because we modeled this in, or our team integrated this in, the plumbing was actually native within Archicad. Because that was native within Archicad, we could pull the elevation. We know that that's accurate. And we could see, well, how do I get from there to there with minimal cuts into the floor? And so that's really powerful. Now, on this particular project, we also had electrical as IFC, and there were some challenges there. But I'm going to jump into the next project because the next project is much larger and is specifically focused around IFC. And I know that I'm talking a lot, sharing a lot, hopefully giving a lot of good information here. So this project here is approximately 45,000 square feet of various medical uses. There's a pharmacy, there's a dental department, there's a behavioral health department, there's different doctors' offices and admin and billing. And so it's really kind of a mini hospital at this point. And all of the structural here was modeled natively within Archicad, but all of the MEP systems were done outside of Archicad and then brought in through IFC. Now, there's some good and some challenging things, some limitations here. For example, when I come into an IFC object, I am not able here to assign any classifications to it. So whatever intelligence is baked into that object as it comes back into Archicad, that's the limit to the intelligence I can assign to it. So I have to know that my consultant is building the right kind of intelligence in, because it really comes down to what do I want to get out of the project? And in order to get that out, I need to make sure that that information is in there as the model, as the project is developed. So, there's a little bit of limitation there. I need to just jump in here for a second. Okay, collision detection. So there is a way within the IFC and Archicad to be able to tell what is happening with the different elements. And so because structure was native and MEP was separate, what we've asked for is we've asked for the MEP systems to come in as individual files for the different systems. So for example, if this will cooperate here with me, we'll see that I have a separate file for the mechanical systems, a separate file for the plumbing systems, and a separate file for the electrical systems. And what this allows me to do is have a very granular opportunity to compare what is happening with the combined elements. Now, this is how you know Graham is a real person here, because that is not where I wanted. Oh, we are actually going into here, into the Hotlink module manager. So we've brought 3 separate files in, one that is specific to electrical, mechanical, and plumbing. And what this then allows me to do here is coming into the design and the model check, I can do a collision detection through here where I pick specific structural elements, and I pick, for example, mechanical, and there are parameters here that define the level of collision that is happening. And then when I run this, I will get a report that tells me that I have all kinds of collisions here. And let's see how this will play with us here. So for example, I have a collision between a wide flange beam and a rectangular duct. And I happen to know that this one is a truss. Well, let's go to this one right here. This is a representation of a truss. And so I'm going to move the window over for a moment. When I double click on that, I can see here that I've got ducting coming down and intersecting and colliding with the truss. And so that gives me an opportunity to convey this information back to the external consultant team, but it's not native to Archicad. So the workflow is a little bit different. And when I look at the list of collisions here, some of these are very, very minor collisions, and I really don't want to deal with them, but it does allow me to see what is happening there. Okay, let's see. We're seeing some collisions. Within the interior design side of this project, the other thing that is powerful, again, now this is a higher end interior than what we had on that first project where I showed interiors. And for example, so again, we've taken this into external rendering engines, which I'm not going to focus on here today, but in developing things accurately within the Archicad model, you can see that we've developed specific materials based on different options, and we might have a physical sample there. We're going to make sure that physically it renders correctly in the inspiration images. And then, you know, through things like this decorative light fixture, we can pull in from external sources and we can embed. And when we bring those in natively to Archicad, we can put all kinds of intelligence to them. Okay, I know that I'm shy on time. I want to make sure there's time for Q&A. So I want to talk just in summary about a couple of things, and I'm not going to go in detail here in Archicad files, but IFC is based on the information that is exported. So we're at the mercy of the export. You see the crazy, you know, missing surface. Okay, our disco checkerboard. That's something that can be solved, but it's a lot easier if that is done before it's exported. So there's a little bit more complexity when we're dealing with external collaboration. When we get into internal elements, and I've touched on this previously, we have the opportunity to classify, and we have the opportunity to give custom properties to that, and we can use the TeamWorks environment. So just in summary here, as I think about the ground that I hopefully have covered in a meaningful way today, there's a range of projects here that I've touched on. There are different methodologies to each of those projects that Resin has experienced, and we continue to learn and play. We know there are certain boundaries, certain constraints that are fixed within our software and with external software. And we have to find the area to play between those fixed constraints. And when we learn to play between those constraints, we can have really great, successful collaborations and integration with our team. So it's really critical up front as you're approaching an integrated design project to recognize what is the appropriate level, what is the necessary level of integration, and what is the desired level. And then there's a balance between those two extremes. And you have to start small and you grow into it. And you have to continue learning. This is something that takes time, but there are great resources available, and there's a lot of power already built into Archicad to allow us to do this. Now, I'm going to wrap up. I want to make sure there's time for Q&A. And so, Nathan, it's back to you.
Technology works, thankfully. This time of the morning here in Brisbane, Australia, it's going on 1:45 in the morning. So, everyone, I could probably chat with Graham. I've seen all the stuff you're talking about, Graham. From my perspective, it lines up a lot with the projects I've worked on myself over the last decade. For people that would like to pose some questions, please put it down in the chat. Thank you so much for your presentation today. I hope that people that are on that journey at the moment, either at the start, in terms of beginning that journey, they take something away and understand the options they have up their sleeve, or for our more advanced users that today you've kind of seen ways in which someone else is working using these integrated design workflows, and it might be of interest to you. Now, we will be back again in a few weeks' time on, depending upon your time zone, it will be on Wednesday, the 13th of March. And we will hopefully have an announcement in the next couple of days as to who will be presenting in the exact topic. But until then, thank you very much for your attendance, and look forward to catching up with you in a month's time. Thanks very much.
Thank you.